Hello everybody and welcome to Software Engineering Online. This is the first online lecture for the CS401 class. If you haven't realized it, we switched over to the online format because of the coronavirus. So this is lecture number 1 of the new format. And today we're going to go over the third assignment. I also adjusted the course slightly, actually just extended some due dates on the assignments to take into consideration the week or half week we got off last week. In the last class meeting, we went over the midterm results. If you missed that meeting, I have emailed everybody their midterm results if you missed it. Unfortunately, we already went over it. I don't want to go over it again. If you have individual questions about something that you may have gotten wrong on the midterm, it is best to contact me, and then we could talk on the phone or, Skype or Zoom or something electronically to answer your questions. So what did I change in the syllabus? The syllabus for the course had the due date of assignment number 3 was originally, it may have been the 11th or the 18th. I don't know. I bumped it up a little bit. So far we've had assignment number 1, assignment number 2, which are on Java programming. And then we had the midterm that was all about Java. And now we're starting into the software engineering use case scenarios, UML, and assignment number 3. So I moved the due date to assignment number 3. I put it on 3/25, which is not this week, it's next week. And then plus you still have another 7-day grace on that as well, but it puts it right before the spring break. It would be good timing for you to finish program number 3 before the spring break, and then we're going to move ahead to program number 4 after the spring break. And we might actually be face-to-face at that point. We won't know until the university decides when they're going to start the face-to-face again. So that's the plan, and so we're going to start in today with the object-oriented design, coupling cohesion, design principles, and I want to show you the software that we're going to use for this as well. So hopefully you're not listening to this at 8 o'clock in the morning, you're listening to this at your convenience, and you'll absorb hopefully more, you'll be able to stop or rewind it, play it again and again until you're sick of listening to me, and so maybe it's probably even better learning environment than the face-to-face to begin with. So we'll see. You can be the judge of that. All right, so the assignment that we're looking at, if I go into the 401 folder and I go into assignments and I look at assignment number 3, if you remember in one of the class meetings before the midterm, I went over the software requirement specification template. And so just to reiterate a couple points on this, because I know it's been a while, the template has spots that you need to fill in. So on the template, you'll see there's a little title page here, and you can leave the revision history empty if you'd like. There's a little table of contents. If you scroll down here, you'll see some stuff in purple. And so it says list any acronyms, terms that you need to define. Well, if you put some terms in here, and remember this is for the mine pump control system that I've talked about already in the class lectures. So this is a continuation of that previous lectures on the subject matter. And we got as far as going over the software requirement spec, and I'm refreshing your memory on it right now. You need to fill in the purple stuff here. And then the reference section, there's a couple of items here that I'm going to go over today. So the use case specifications document, the UML use case diagram, the class diagram, and the sequence diagrams. So these are diagrams that you're going to put together using an online tool, and you're going to save the diagrams and you're going to post them in references to them in this particular document. So this is step 2 and step 3 in the assignment description, and step 5 and step 6 in the assignment description. We'll take a look at that momentarily. But the rest of this document, there are other things you need to do. For example, filling in the product architecture section, the constraints, everything in purple needs to be filled in. That would be the functional requirements, the common requirements, the module requirements. If you break the system out into modules, which you should, you'll have specific requirements for each one of them. Do your best. You'll probably capture about 30 to 40% of the requirements, but do your best. There's some examples in here. So for example, where it says external interface requirements, provide module specific requirements as appropriate. As an example, 3.2.1, the system must have an interface to use the university billing system administered by the bursar's office. Well, that's an example. And you notice down here it says example. These are examples. So you take that with a grain of salt. There's not things that are appropriate for this particular system. These are just example of requirements. This document is broken out into functional and non-functional requirements. And I talked about those already in the class lectures as well. So this is really just a practice exercise to see if you could fill out a requirement specification. In the real world, this would be filled out over about 3 or 4 months worth of time, and this is pretty much the result of the analysis that's being performed on the project. Okay, so let's take a look at assignment number 3, the document itself, and try to get a feel for what we're doing here. So in assignment number 3, I've gone over this scenario. It's the mine pump control system, and I'm not going to go over it again. It has these sensors and things. And then there's some steps in here. It says complete the following software engineering tasks. Okay, so number 1, you're going to fill out the requirements spec. So you can do that first, or you can start on it first, or you could actually wait till last on it. You do not have to do these steps in this order. And then the second step, you're going to perform requirements modeling engineering. And you're going to specify a set of essential use cases and describe the functionality that your business or solution system will exhibit. So you're going to identify the goals, the sub-goals, the actors, the dependencies, perform scenario modeling, and group the scenarios as needed to identify essential use cases. Okay, so we have actors and we have use cases. That's what I want to talk about right now. So for each one of these use cases you have identified, you'll fill out this use case specification description. Here it is here. It's a template that you fill out. So what are you going to do? You're going to go through and you're going to list a bunch of actors in the systems. So who are the actors? The actors are the people who are going to use the system. For example, the admin, the supervisor, the mine shop employees, and then there's this automatic behavior that occurs that doesn't really have a physical actor, but it has like a mental one. It's the system monitoring, which is actually an actor, but it's not a human actor. It's an automated behavior of the system. So once you identify the actors, then you're going to understand. You're going to try and figure out the scenarios that they're using the system. So they turn on the pump, they turn off the pumps, or they turn on and off the sensors. They might be playing with settings. They might be overriding it. Those are the ways that these actors are using the system. Those are actually called the use cases. So what you're going to do is you're going to, for each one of the use cases that you're going to come up with, you're going to fill out one of these templates. So you have a use case ID, you have a use case name, you have the relevant requirement, what is it? The primary actor, is there a sub-actor to it? Preconditions, post-conditions, basic flow of the main scenario. And then the extensions of any alternate flows. You might not have anything in that. And then any exceptions that might occur. And any related use cases. Does it work with any of the other use cases out there? Once you come up with these use cases and the scenarios that are associated with it, and this might all make sense when you see the diagramming tool, then you're going to draw a UML use case diagram using the UML modeling tool of your choice. And you can draw them by hand, or you can draw them using the tool. And you're going to document all of the UML use case diagrams using Microsoft Word, which means you're going to copy and paste and stick the use cases into a document to put them all together. All right, let's talk a little bit more about what this use case scenario is and what this use case entails. So there's a program out there that's online. It's called Visual Paradigm. I'm going to go to Google real quick here. And I'm just going to type in online visual. There it is, Visual Paradigm. Now I've already signed up for a free account, so I could use the login. But I'm going to show you And I might be logged in. I might have to log out. No, I'm not logged in, which is good. You go to a website. It says online.visual-paradigm.com. It's free. Free forever, it says, as it says down here. You can sign up for an account if you want. I'm just going to click on this thing. It says, yes, we're using cookies for sure. I'm going to go in and see if I can figure out how to log into this now. I was just there. Let's see, get started. Get started for free. Let's see. You have to create an account. I've already created an account. Yep, I have. If I log out of my account, I see I get into a login screen here. Log into your workspace. And if I bookmark this page here, I don't think I'll do it actually. I would only have to click on login, provide my login information. Oops, this was my email address here. There we go. And now I'm in. And so first thing you're going to do is create an account. You don't have to use this software if you don't want to. There's nothing to install on your local system. This is completely online, as it says. If you want to use this software, it's easy to do. You have to first create an account. And then the Visual Paradigm Online Diagrams is where you want to go into. When you get into this here, on the left-hand side of the screen, you see the standard set of diagrams. There's a search or a filter here where you can click on, let's say, case, for example, and it says use case diagram that popped up. Or you can do it the old-fashioned way and scroll through the bottom here, and they're really out of order. They're out there if you have to know what you're looking for. So there's user flow, mobile app, user flow, use case diagram. If you click on use case diagram, you see a bunch of diagram templates on the right-hand side, and they're showing you examples of use cases. For example, this car park system. If I click on the car park system, it's going to prepare my diagram. Here we go. You can see what a use case diagram looks like. You're going to create one of these use case diagrams. These are the use case scenarios. For example, there is a display, and the display displays a parking space availability. So there's a display that's in, this is what I was mentioning before. So sometimes these actors, and this is an actor over here. It looks like a stick figure. This actor is not a human, it's a display. There's some sort of a display, like a sign sitting out there that displays the spaces that are available. And then this guy is a human, hopefully, he's a car driver. And then we have a building manager. So we have three actors in this particular scenario, this particular diagram. And so you can stick it all in one diagram. This would get a template. Over here, we're going back to this use case specification. There's three of these that would be filled out. Three of these, use case ID number 1, and this would be the display. Or you could just give it like 101 or 100. Use case name, display. Relevant requirements. Well, there needs to be some spaces available. Primary actors, the screen, the people looking at the screen. Precondition requirements that, prior to this being a valid thing, there must be some spaces available. Basic flow of the scenario, the user looks, or people look at the display shows which spaces are available. Related use cases, I don't think there are any. Nothing has to be performed before this one. Okay. The next one here is the car driver. He enters the carport or he exits the car park. And so these are the two actions he can do. The building manager, well, he configures the system, he generates reports, and he updates the member database. And if we go back up to this car driver, it includes other scenarios. For example, when they enter the car park, it includes the enter car park method or scenario where it has to say, okay, we have a car in there. And then the exit car park also extends out and includes the enter car park, which is nothing more than a space holder that says, hey, we have a car driver, we have a car in here, and they're going to want to use one of these spaces. So it's not really showing you all the functionality in the system. It's only showing you how the system's being used. How do we create these things? We click on these little guys and we put them in here. And we have little arrows and things. I'm just playing around with it right now. We add the items to it. There's a little bubble here. We have a use case. You know, your diagram might look like this. It might not look like this. You could edit this diagram. You could play around with existing diagrams, or you can build them from scratch. So I'm going to go back to the previous screen here, if I can get out of this one. Oops, it's not exactly what I wanted. Let's see. Bear with me for one moment. Let's just go back here. Oops, yeah, leave the page. You can see one here for ATM, and in the ATM scenario, you'll see that there's a big ol' box here that encompasses the ATM behavior. We have a customer who does a cash withdrawal, a cash transfer, donates money to charity. Some of these guys require a login. They handle invalid passwords. They handle an abort if the password is invalid. If you thumb through some of these, here's a ticket manager. You'll see different scenarios with different examples. You're going to create one of these for the mine shaft pump system. And watch, it's going to fail. No, it's preparing it. The system is kind of slow right. My internet access is kind of slow right now. So we'll just leave that one alone. But as you thumb through that, you have a passenger service. They're all in different themes. Here's a software development project. Here's one on structuring use cases. Hopefully this one will load. They should load. Let's see. If you pay for the system, you'll be able to save your diagrams online. If you don't, well, you'll have to take screenshots or save them locally. If you go through the menu, for example, file up here, you can export it as a PNG file. So if I exported it as a PNG file, and I say export, I can put it on my hard drive. Drawing is too large for that. Let's see, one second. Export as PNG. Export. Change the, oops. Okay. Hold on one second. PNG. There we go. Let me just change the name here a little bit. Download. Let's just download it. The drawing is too large. Interesting. You might just be better off taking a screen capture of it. Having a save as. I'm not quite sure where that one went. Let's see. Device. No, that's not where I want it. Okay. Interesting. Let's see. I'm just trying to figure out how you can save it. Let's try Google Drive. All right. Well, you should be able to figure out how to save it. Worst case scenario on my computer, I'm going, let's see, Command Shift 3 takes a little picture of it. And then I can take and draw on it, or I can cut and paste the picture out. So you'll have to figure out how to capture the image, essentially. Actually, that's how I can capture it right there. Edit, cut. File new from clipboard. There we go. There's my diagram right there. So anyway, you can figure it out. I know that you can probably spend a little bit more time and figure out how to save it somewhere instead of having to do a screen capture. But these are examples of the use case scenario system. Oops, let's see what happened with that one. There we go. And it's in the use case diagram. Now there's also another one you're going to want to put together. It's the class diagram. So if I come up here to the class diagram, Because you guys have all taken Java, here it is, class diagram, and you're all familiar with the model view controller, yes you are, and you're all familiar with the concepts of creating objects. The simple class diagram has nothing more than objects in it that are connected together via symbols. Well, okay, this one's empty. Let's pick one of interest. How about this one? There we go. This one is a class diagram for flights. And I mentioned this to you before, and I've written this on the board already in a previous lecture. But these are the objects themselves, and the objects have the three components: the identities, the states, and the behaviors. And really what you're doing with a class diagram is you're putting together a visual representation of the objects. So for example, we have a passenger. The passenger is going to have a name. The name is going to be string. It's going to have a mileage card number, which is going to be a string, and a status. And then they're going to have some credit miles, consume miles, cancel miles. The name could be compound. There could be a first name, a middle initial, a surname, a salutation, excuse me, a title. The booking could have a kind, a date. And we're connecting them together via relationships that they have. For example, the passenger is going to book a flight. So they're booking, and they're booking flights. And so you put little words on here if you want to represent the relationships between them. And these are just lines that are connecting them together to show how they're going to be used. And so the flight has a from and a to on an airport. So there's a connecting, a flight might have another flight. This is a recursive relationship. The flight might have a relationship with another flight, might have a connecting flight. There's a relationship with a to and a from an airport going on here. So you're going to draw them together, you're going to connect them together, showing the relationships that they have. And then the methods are essentially used in the object-oriented fashion to create the behaviors for this communication. So if we go back to the document with the assignment description on it, we have the use case specifications, the UML use case diagram, and then the step number 4, which is optional, is called the brainstorming or the CRC cards. Cards are optional, where you're going to dream up, you're going to brainstorm a list of object candidates, and then you're going to put them together. So these are the object candidates that are going into the class, create the class diagram. So the class diagram is this. These are the object candidates. So you might want to brainstorm before you start writing and creating these objects, because you don't want duplicates, or you don't want two objects that are pretty much doing the same thing. So think about programming and think about how you would assemble and how you would write the code to create the objects to make the mineshaft pump application work. Divide it out into objects and then document the 3 areas or 2 areas. They all need to they all need a name. You have to put names on them. And then sometimes you'll just put data members, sometimes you'll put both the data members and the member functions, if you know there's going to be a function. For example, on the booking object, we know there's going to be a reserve, a pay, a cancel, a change, a start off, a handle. We know these methods are going to exist, but on the flight, we don't know if there's going to be any methods on the flight. And then on the mileage account, we don't know if there's going to be anything on the miles account either. Or the airport, we don't know if we're going to have methods on the airport. Instead, we're just going to hold data about the miles account, or data about the airport. So we just put the data members in here. So don't think you have to fill out all 3 areas. You know, the first area, the name or the identity of the object, is a must. But the rest of the items that you're sticking in the object itself in the class diagram, and this is the class diagram, are sort of optional. Put in what you can put in. So this will help the programmer figure out this is the data or these are the data members or the member functions that belong to this particular object. So after you do your brainstorming, then really this is the brainstorming stage, then you're going to create these this class diagram. Now it says diagrams. You only require one. In fact, for all of the steps in this particular assignment, one is sufficient. So one use case scenario, use case specification for each one of them in the scenario diagram. Just one is necessary. And so one use case diagram, one class diagram that has all of the classes in it. For the mineshaft control system, one is really all you need. And then you're going to do this last one here, which is called creating the sequence diagram. So just as you might imagine, there's a diagram that says sequence on it. But before I continue, if you go through the class diagram, you'll see, there's a file output, company structure. There's a bunch of there's a lot of examples in here, it looks like. Ticket selling, the ticket selling one was pretty cool actually. So you'll see a lot of examples. I highly recommend looking at the examples. I will also point out some readings for you so that you can get familiar with the class diagram as well. And I might even recommend some YouTube videos or something to help you get a little bit more practice with that as well. We'll see what I can come up with. So the last one we're looking at is the sequence diagram. So if I come back to the sequence diagram, this is the one that's going to be more interesting to you. So in the list over here, I see sequence, so I'm going to click on the sequence diagram. And you're going to see these are all sequences. So this mineshaft control system is a sequence-focused application. There's a bunch of sensors with a bunch of mechanics behind it, with a bunch of sequences that occur when the sensors pick up certain conditions. So this is the diagram of this entire project that's actually going to be the most interesting for you to write. I'm going to click on this one. It says hotel reservation. So you could think of a sequence sort of like a to-do list or like a series where we're going to have one event lead to another event, which leads to another event, which leads to another event. It could come back to the beginning or it could just terminate. So this one here only goes in one direction. And so we have a UI window where we make a reservation, and then the reservation is might be a chain hotel, and then the make reservation could go from the chain, like let's say it's like Hilton or Marriott's, could go from there to the actual location of the hotel, to the individual hotel that's part of the chain. And then from there, there's a sequence that might loop around looking for an appropriate room to see if there is a room at any one of the hotels. So once it finds a hotel, finds the room, and if the room is true, then a reservation is going to be initiated. And then there's going to be a notice, so there's going to be a confirmation that is going to be sent that says, okay, you got it. You registered. So you're looking at a sequence of events that are happening in one direction or two direction. Here's make a phone call. Let's see what this looks like. And what you're going to do is you're going to diagram the mineshaft. So the caller picks up the phone. Okay, the phone. In the old days, probably most of you hopefully have been familiar with the old style telephone. Cell phones don't work this way. But in the old days, you picked up the receiver and you heard a dial tone. So a dial tone was sent back to the caller, and I said, okay, now you can dial. So you pressed in some buttons. And then there was this ring that you heard, like ding, ring. So now you pick up the phone. If this was a cell phone, modern day times, you don't even pick up the phone. The phone's right there. It's just go in here and skip down to the dial. You just dial, and then when you dial it, you still hear the ring. You still hear it ringing, and sometimes there's a ringtone or something. And then the ring goes to the recipient, the person that you dialed, and then they can answer the call, pick up the call, answer the call. They can say hello, and then the hello is going to come back to you. And then, well, you can go say hello or whatever. So this is a sequence diagram. This is what a sequence diagram looks like. This is what you're going to be creating for the mine shaft. So here's your sequence diagram. And if you follow through some of the other examples in here, you'll notice there's a simple ATM machine. Insert a card and put your pin in. Ask for, I don't know, something to do from a menu. And then process, withdraw all your money or do whatever you're going to do with it. So while that's loading, I'm going to come back to here. So at the completion of the assignment, you're going to have the following to submit. You're going to have the SRS document. That's where you're going to list out all the requirements of the system. And here's what's going to happen. As you're creating the use case specifications and you're doing the use case diagrams, the class diagram, and the sequence diagram, you're going to learn about this system. And as you're learning about the system, you're going to learn about features that it's going to need to have. So what you could do is fill in the SRC, the software requirements specification document. You could do that last. If you did that last, you probably have a better idea what's actually going to be in the system, because you're going to learn from it. Now, don't get too carried away with the specifications. And, that's where most students have most of the questions. They're like, well, if I don't have any of this stuff? Then if you don't want to do it this way, then just describe it in a couple of paragraphs. That works too. Basically, the idea is you have this template or this description of what these use cases are, because the diagram really doesn't say everything. It just shows the actors pointing to the activities. So usually there is a specification or a description as well as the diagram. They're not in the same, they're usually separated. So the UML use case diagram just shows the stick figures pointing to the stuff. The specifications are showing the descriptions that the pictures aren't saying. The stuff behind the pictures. Class diagram is the class diagram. You can't get away from that one. Sequence diagrams, well, those are the sequence diagrams. And each one of these is showing a different part of the system. So it's like if you took a picture of a building and you took it from all the different angles, from the top, from the sides, from the bottoms, you'd get a better idea what the building actually looked like, which is what you're doing here. So you're describing, you're doing everything but writing the software. So you're going to describe what the software is going to look like using a class diagram, using a sequence diagram, and then using use case scenarios to say, how is this thing actually going to be used? You're going to take all of it, put it together. It gets put inside of the SRS document. So these steps 2, 3, 5, and 4 was to brainstorm. 2, 3, 4, you don't have anything to deliver. 5 and 6, they go inside of the SRS document. And so you're just going to submit to me, if you'd like, just the SRS document along with the step 2, 3, 5, and 6. You can put them all together into a zip file. You can put them on a shared drive. You can do a number of things with it. When you do that, it doesn't really matter. I'm not expecting it in any particular format. I just want all the pieces. So if you have any questions about this, it is best probably at this point to email me, or we can also set up a Zoom session and I can troubleshoot any problems or things that you have with this. Take a stab at it. It is an exercise to get you familiar with the concept. Oh, that never loaded. Well, my internet access is running slow. It is an attempt to get you some practice or some exposure to the software engineering process of creating UML documents along with a software requirements specification to better understand the system and to create a description of the system that can be given to developers. It looks like I have it loaded twice. So that they can build the system from there. So I'm going to stop this video at this point because I've accomplished what I needed to. I will probably, we'll have more videos to come, so stay tuned. If you have recommendations like, oh, I can't hear you or something, or you have feedback like, oh, the screen's too small, or you're talking too fast, or I don't know. If you have critique for me, I'm sure these videos will get better as I continue to record them. I'm a little out of practice, but if you do have some suggestions for some improvements, I'm totally open to that. All you have to do is email me. Or if you want to see something more about something, let me know. And nobody's going to ask this question, but you don't have to do all of the diagrams over here on the left-hand side. And you might want to play around with it. There's a, if you take a database class, there's one here for entity relationship diagramming, which is actually kind of cool. There's Gantt chart if you get into project management. Google Cloud, configure cloud services too. So it's a diagramming tool. It has lots of different types. I think there's a roadmap in there too. Lots of different types of diagrams. So have fun with it. If you come close, you'll get 100% on the assignment. It's a practice exercise to get you some exposure to this concept. There really is no right or wrong answer, so don't worry about getting your diagrams correct. It's an attempt to have you dabble, to experiment with how these things are done. And the more practice you get, obviously, the better that you're going to get at it. So I hope you enjoyed the lecture, and stay tuned for more, and have a good rest of the week. Thanks for watching.